Okay, combining like terms. This is the next foundational skill on top of combining integers, because we use that same skill, combining integers to combine like terms. We use the term combining like terms to add polynomials. That's all it is. It's just an extended version of combining like terms. So if you know how to do this already, then you're set up and ready to go, but watch the video just to be sure. So rule number one, the exponents of the variables, and it has to be all of them, must match exactly. So if you look down here, let me get a highlighter. If I look, the x squared here, the x is squared, and so is this x, it's squared. The y here doesn't have an exponent, which means it's a 1, right? And neither does this one. So that means whatever x and y stand for, then they are standing for the same number. Okay, so remember this is x squared. So if that was 2 squared, remember x and y represent numbers we don't know. So if this is 2 squared, so that's 4 times 3. Let's say this would be 3. That would be, this is 12. So this would also equal 12. Okay, so if I look over here though, x squared and x squared. So those match. So those are good. But if we look at the y, this is a y to the first power. This is a y to the second power. So we can't add these. We use the same analogies we did over here, that these variables stand for 2 and 3. This would be, again, would be 4. And this would be, again, 12, right? Because we're multiplying. Here, 2 squared, again, was 4. But 3 squared is 9. So this number would be 36. Okay, so see, they're not the same numbers. So basically, we can add these. The other way you can look at this is though these are boxes, okay? This box has 2 x's and 1 y in it, and there's 3 of those boxes. This box has 2 x's and 1 y, and again, there's 2 of those boxes. So altogether, I have 5 of those boxes, 5xy, okay? Or x squared y, sorry. So I have 5 of those boxes that have that in it. And we'll go over this again in the next on the next slide. But this one, again, has 2 x's in it, but 1 y, just like these do. But this one, and we have 3 of those boxes, but this box has 2 x's and 2 y's in it, in each box. And I have 5 of those boxes. So these aren't the same kind of boxes. So if I was taking inventory, I couldn't say I had 8 of those boxes because I don't have 8 of this box or 8 of this box. I have 3 of this box and 5 of this box. They're 2 different boxes. So therefore, I can't add those together. And that answer stays as 3x squared y plus 5x squared y squared. Okay, can't add those together. So it stays exactly like that. Okay, so rule number 2, just like I said on the last slide, we add, remember we use that term to mean the same as combining. We don't change any signs. We'll see this again when we go to subtracting to understand why I call it that. But we add by combining only the coefficients or the big numbers. We leave the variables the same. Okay, so if we look here, we have to double check. We have 3x squareds and a y, or we have x squared y. Here we have x squared y. So that means they're the same thing in both those boxes. So I can add them together. So 3 plus 2 is 5. And then the variable stays the same. So it's x squared y. Okay? Just like here. So I have negative 9 plus 6. So this is where that combining integers comes into play. Okay? If you don't know those, then you're going to struggle with this. If you struggle with this, then you struggle with the next piece. So if I have 9 negatives and 6 positives, then I have more negatives than positives, so my sign's going to be negative. 9 minus 6 is 3. Don't worry about the signs, just subtract them. So if I look and just double check, we forgot to double check this before we started, but the x's are both squared, the y's are both 1, and the z's are both 1. Doesn't matter how many variables there are, you need to make sure that they're all the same. And that would be our answer for this one. So I have some problems with the answers so you can try them. Make sure you immediately know how to do them. okay? And then we'll move on to the next part.